Yeah, I'll record this. This is going to be some ambiguous case review. Solve triangle car. So if we draw a triangle and I find, you know that activity we did with the 5 centimeters where you tried to draw as many triangles as possible? I find when you draw these triangles, if you make your triangle with the 40 degrees here, so that would be angle C, and we know that CA, put the one that you know right there, CA is 10, and AR is 9. Is this the ambiguous case? This is review, so you should know it already.
Yes.
Hmm?
I was doing my quiz while you were doing this.
Okay.
Yeah, I guess.
Oh, yeah.
Do we remember how many triangles are possible? Is there only this one triangle possible? Or is there 2 triangles possible?
Only way.
Okay.
It's more than two, right? No, there's two.
No,
It's
yeah.
greater than 10, there's more than 2. Oh, look at 9.
This is the ambiguous case. Since the opposite side of the angle is less than the adjacent side. So since that side is 9, there's one triangle. Well, we don't know. The ambiguous case, ambiguity means something's unclear. We don't know if there's 2 triangles. There might be 0 triangles. Remember when we drew the side length and it wasn't long enough to make any triangle possible? Maybe this is a case where there's no triangle possible. Maybe this is the case where there's 2 triangles possible. So what we do is we assume that there's 2 triangles possible. So I'm going to redraw C and A, 10 here, 40 degrees there, and draw another one that 9 degrees has come around and made an obtuse angle. So we have 2 options, option 1 and option 2. We begin by solving this the same way that we solve a regular sine law. We know we can use the sine law because we have an angle and the opposite side. So the very first thing that we could solve for is angle R, because it's opposite the 10 and it's something we don't know. So setting it up with our sine law, and a lot of you really like this sine law because the setup is really easy. We want to find R, so I'll start with sine of R. Opposite that is the 10 equals sine of 40. Opposite the 40 is the 9. How do I get sine R by itself? Times by 10. And so if I type that into my calculator, sine of R I'll use my fraction button and everything, make it look exactly like we see. 10 sine 40 over 9 equals 0.714. And if you were solving for angle R, you would do sine inverse. And this is no problem so far, but the next part is where things get a little bit interesting. 45.6 degrees. Or why can I also say that it's 134.4 degrees? because of the cast rule. Okay? This is positive. According to the cast rule, sine is positive in quadrant 1 and quadrant 2. So when I do the first one, the 45.6, that is technically my reference angle. And my reference angle in quadrant 2 would produce an angle of 134.4. And in this case, if I go back to my original triangles here and I label them, okay, I have a possibility of 45.6, or 134.4 degrees. Are both of those triangles possible?
Yes.
Yes, they are, right? Because this doesn't add up to more than 180. In fact, this adds up to 85.6. What would we be left with? 94.4 degrees for that one. Then it would add up to 180. And these two, what do they add up to? They add up to 174.4. That would make this angle right here 5.6 degrees. So we do have two triangles that are possible. What did the question say to begin with? It said solve the triangle. Solving the triangle says you have to find all the angles and all the sides. So on triangle 1, we found all the angles, but we still have one more side to find. And on triangle 2, we found all the angles, but we still have one more side. Yes? I knew how to draw triangle 2 because of this black note right here, that I recognized that the angle or the side opposite the angle was less than the adjacent side, so this could be the ambiguous case with two triangles. Okay? So that's the key, this note right here. Since the 9 is less than the 10, there could be two triangles possible. What do we have left to do? We have to find side A on triangle number 1, and we also have to find side A on triangle number 2. Again, we can use the sine law. On triangle 1, it would be A over sine, and if we look back to our triangle, opposite of little a would be 94.4 equals, and we can use 40 degrees and 9 for the other side. Yes?
When you do sine law, you don't round up the degrees that you get for the angle?
You don't
Round it up?
You don't round this angle up?
Yeah.
You would want to try what we're going to do. So when we go back to our calculator here, I'm going to go 180 minus 40 minus my answer. There's my 94.4. I'm going to save all of those decimal places while I work, because I might make a mistake if I round early. Okay? So 94.42. How do I get a by itself? Multiply both sides by sine of 94.4. I can type that whole thing into my calculator. I can use my, oops, clear. So I'm going to go 9 times sine of that answer. So I can go second answer, keeps all of those decimal places, divided by, what was on the other side?
40.
Sine 40, thank you. Enter, and we find that A is 14.0.
So
Were there units involved in this question originally? Centimeters. So I need to make sure that I include centimeters for my answer. On triangle 2, it's going to be A over sine, is it 5.6 degrees? Let's have a peek back at our triangle, make sure I've got the numbers right. 5.6 degrees. So I need to make sure that I'm using all of my correct decimal places. First of all, my reference angle was 45.4. So if I do 180 minus this answer, I had 134 on the bottom. Then 180 minus that answer minus the 40 degrees should give me that 5.6 that I had before, and there are all the decimal places. Now that I have those decimal places, nine sine 5.6 divided by sine 40, so go to my fraction. 9 times sine of 5.6, so I'll get that as my answer, divided by sine of 40. A is 1.36, rounded to the nearest tenth, 1.4 centimeters. So one of the things in these questions where it says solve completely is go back to your triangle. We figured out this one was 14.0 centimeters. We just figured out this side was 1.4 centimeters. Go back to the triangles that you've drawn and make sure that everything is labeled. So we're going to do one more example. Okay, we're going to look at another ambiguous case one. Another car triangle. Again, start by drawing it. Label your angle here, that's angle C. We know CA is 10, and we know that AR is 4. Is this the ambiguous case?
Yes.
Yes. So there could be a possibility of 2. Oops, there, I'll just erase some of that. 4 and 10. And the reason I'm going to show you this ambiguous case is for the following. So we set up our sine law like normal. Do we know an angle and an opposite side? Yes. So what can we solve for first? We could solve for angle R. So we go sine of R over 10 equals sine of 40 over 4. Multiply both sides by 10. 10 sine 40 divided by 4. I'm going to type that into my calculator. And I get 1.6. And now I want to find my reference angle or find angle R. So I go to my calculator, go sine inverse of that answer. And then on tests and quizzes, what happens next? Our hands go up. Mr. JR, my calculator is doing this. What's wrong? Oh, I didn't. So let's go to it. Let's finish the bracket. Still broken. It's just, it isn't doing anything wrong. It isn't doing anything wrong. There is no solution. Does it make sense when we look back at this that maybe 4 was too short, that it would never touch? So in this case, this is the example. If you get that, there's no solution. You're done. You solved it. That's a great.
Easy 3 marks.
That's a great one. Okay.
That's gonna be
One thing to look at. Can you write 1.6 as a fraction?
oh my yes.
What would it be? What's 1.6 as a fraction? 8 over 5. Okay? Good. Or you could write it as 1.6 over 1. What does SOHCAHTOA mean for sine? Opposite over hypotenuse. Can you draw me a right-angled triangle where the opposite side is 1.6 and the hypotenuse is 1?
No.
It's impossible, because the hypotenuse always has to be the largest. And so the fact that this number is over 1 makes sense why there's no solution. But the first time you see that on your calculator, you put your hand up and say, what's wrong?
Will you say like, no, what will you say? Will you be like,
I'll just say there's something wrong with you. I'm kidding.